Yeah, it's fine now.
Yeah. Okay, so are we good to start?
Yes.
Yes, Amrita, you can go ahead. Thank you.
Sorry, I didn't catch that.
You can go ahead, Amrita. Yeah.
Okay. Amarjit, let's start with a small intro, like what you've been working on actively in last 1 year and your key skills that you are interested in, uh, and few tech stacks that you worked on and so on. If you could brief a little bit about that.
So, thank you for asking. My name is Amarjit. I am having 7+ years of experience. Currently, I'm doing for the Java development. So, the technology which I used, Java with the Spring Boot, microservices, a Spring Cloud component as a backend. Some of the exposures in front end as a Angular 9. Also, I have a good experience in AWS Cloud Services. So, AWS Cloud Services mostly I use multiple services while we deployed application or monitoring the application. Coming for coming for this DevOps, some of the DevOps tools. Also, I use like Apache Maven, Jenkins, Jira, GitHub, ELK, Splunk, and database side I have Mongo and Oracle. So these all are the technology stack which I have experience. Also, I have a good experience in different domain which I work like banking, telecom, e-commerce, and health insurance. Currently, the project which I am working, that is health insurance. There I am doing customization as well as implementation based on the client requirement. So the project is like as a health insurance portal, like where we need to manage if any type of insurance or any type of customer want to take any insurance, then we how we will process the portal internally operations. So once he will take, then we have a like we need to take the order ID, and after that we will process that order ID. So we have to check particular store, and then we need to calculate the payment, and then payment will be calculated, then users will notified, and if any promo code and all will be there, then we have to enable this customer to applicable for this particular promo code. So that type of schedulers, batch and all will be configured here. So my role and responsibility here, we are following agile. So based on the agile, whatever the sprint task will be defined, we need to work. So on the Jira ID. So currently I'm working to develop a microservices. So while we are developing a microservices based on REST template and Kafka, which I use, which need to be communicated for multiple microservices, either synchronized or asynchronized way. So messaging I used for the Kafka as a asynchronous communication. While develop application, then after that we'll have some deployment which will be there. So once it will go for the deployment, before that we need to check all the configuration changes, security validations and all those things, so that our deployment will go smooth. And also after post deployment we'll have a call to check all the business logic and functionality, and check the logs which we have enabled is correct or not. So that type of work I'm doing on daily basis on current project.
Okay. So you mentioned about working with Angular on front end side, right?
Yeah.
So what was that about? Can you?
Yeah, yeah. So our application is, as I told, health insurance based project. So there we need to manage a customer to take any type of insurance. So how this will be happen? So the customer will have a landing page that is called a UI web application. So through that, customer will enter the detail and apply for the process. So we have a that page is a Angular based. So Angular 9 where we are using, like suppose customer once he will come, then we'll have a registration page, login page. Once he will log in, then they can compare multiple insurance with the third party also, what type of functionality and features are there for that. Which one he have to select, so that multiple business operations which will be performed. So that UI which have Angular.
Mhm. Okay. Can you go a little bit into the architecture of the flow, how it happens, and the tech stacks involved? Maybe you can just share screen your notepad or something, and we can try to do an HLD.
Okay. HLD. Okay. Just a minute. Okay. Are you able to see my screen now?
No, you would need to click on share screen.
No, it's fine. Are you able to see my screen?
Yeah, go ahead.
Okay. So if I'll create a SLD from our application, so here, okay. So here we have a this is basically a three layer of architecture. So here UI have, so that UI base will render have a and then microservices, so that microservices and then database services page, and then database we have communication, so that we have multiple microservices. So in this UI will have a login page, registration page, and others. So here microservices which request will come from this UI, so that will go for the service request. So once it will go for this request to this here server controller. Then it will go for this request, and after that before going for Angular application, the microservices, so we have multiple microservices are there, so that we need to be communicated. Here we have a API gateway that is called cloud will come. Wait, so Joule, and then here we will have a service registry. So in that service registry have a Eureka service registry. Then which will be communicated with different microservices. So microservice 1, 2, 3, 4, 5. 4 I'm taking here. 4 I'm taking, so that microservices 1. This is for order microservice. And then we'll have a subs. This is for a store will validate click this, and then we'll have a payment and notification. Just for I'm checking payment notification. Yes. And now we will have to compare. So here these all are there. So a service registry which should be communicated from all. So will be communicated with this one. Okay, now here this backend application UI will call somebody here gateway and then service, then database. The database will have a two type which we have followed here, Mongo and Oracle. And we will go for this one. Go for the notification and all this. Go for this one. And this we have a business logic which have a Saga that will be maintain this transaction. Okay, so here instead of this database we'll have a server pattern transaction management server. This will go on these three and then it will go for the business requirement. This one also will have a Saga patterns. All the microservices will be maintained. We have this one. That will call from there bidirectional. Yeah, this way I think we have multiple things are there inside.
Mhm.
Hello.
Yeah, so what are the microservices here?
Mm,
Order, store.
yeah, order, store, payment, and notification. Now, four I have mentioned, but we have multiples are remaining others are also there. So while our request is coming from the UI, that will go for the dispatcher through this API gateway. That API gateway we handle like what type of request is coming and which microservice is related. Then it will go for the particular registry, not in microservices, because for the security reason we implemented API gateway and registry. So that API gateway will send the request details. I want this request from this microservices. So service registry will check our this microservice has been registered in our services. Then they will communicate with the particular microservices, and after that microservices will have a either have a database operations which will follow for the business operation. So suppose in a single microservice have communicated with three microservices, and after that they need to update the transactions and all. So for that we'll have a saga pattern which need to be implemented in our microservices. So this if all the services will commit finally and do the successful transaction, then only transactions will be committed. Otherwise, if any microservices and all will fail, then we will do the revert and all. So how we will do? So that saga patterns we use relational database and relational database transaction management, which will be performed for all three microservices. But in notifications we use different services of database as a Mongo, because we need to notify the customer on depends on the data sync up. Like if customer has done the payment, then don't need to be sent again as a reminders or something. So for that we don't have any transactions related things is there. Directly we can go for the notifications which will be stored in our Mongo as a temporary database, not a permanent, and no need for the taken care for the transactions. And we have to fetch the detail and update to the SQL database where we have notified the particular customers and all, or maybe customer has done the payment like that. So these type of things. Apart from this we have multiple others also there, like Kafka implementations and others thing which we have to describe.
Okay, so you have worked on all of these microservices, is it?
Yeah, most of.
Mm-hmm. So, uh, like, what is microservice? If you have to explain it to a newcomer, how would you explain it, and why
My
should somebody use?
Yeah, microservice is just like whatever the application before was there, monolithic and SOA based. Now they will divide it in monolithic application in different module is called a microservices. Microservice is multiple advantage and disadvantage also there. Like while we created a multiple modules like independent developer or others, independent developers testers can develop the application, test the application, and deploy the application. So like if on frequently basis right now we need a multiple features which we need to enable in our application. So daily we need a deployment, so daily we have a new features need to be updated. So while if you will go for the monolithic, then you have a downtime for this whole applications will be down for particular some time, so that no users will do any type of operations or actions in the particular website. But in microservices, if you want to customize some of the other microservices, then you have to close or maybe stop for particular microservice. So remaining microservice will work independent. We can develop easily, we can understand, easily we can track the application, monitor the application. While you use microservices, then we have multiple others third parties tools and jars are there. Through that we can also monitor the application, add the dependency, and track the applications like that. So this type of many factors are there. So
Okay. Um, so, what is the difference in the architecture when compared to a microservice versus a Spring MVC application? How does the flow work?
yeah, So in a Spring MVC flow will have a directly will have a three layer of architecture. So that three layer is architecture, nothing will have a others. Like we have a JSP or Java UI layer. UI layer will communicate it with our backend application, and backend application directly will check the database operation. No have others like async communication securities and any transactions related things, or maybe Eureka service registry, other security purpose API gateways and all is not there. But while we go for the microservices communications, we use a Spring Cloud component. A Spring Cloud component have a features which will be provide multiple things. Like if your applications have a say you want to secure your application, so directly instead of direct request which is communicating in MVC pattern of a UI to backend application, but here that is not happening. Directly UI will not be communicated with our backend applications. We'll have a two layer in between, like API gateway, Eureka service registry and all will be there. And we have a, while we handle the multiple applications, so that internally we have a like we have a load balancer, so that reruns and all is there. And also we'll have a configuration server, so all the config changes and all, instead of microservices we have a application.yaml, but here we can create a configuration server there. All the microservice configuration details will be auto refreshed here, and automatically will be deployed. So like whatever the small changes and remaining changes of hard coded changes, something will be there related for config changes, that we can create in the config server. So respective microservice will be auto refreshed. And yeah, I think these things we have.
So you mentioned about annotations, right?
Hmm.
So what are the specific ones that we use in the Spring Boot application?
Yeah, Spring Boot. Yeah, so Spring Boot applications will have a multiple annotations are there. Main is at the rate Spring Boot application annotation, which will be taken care all three, like at the rate configuration, enable auto configuration, component scan. So whatever the property file and all you are defining in application, no need to inject the bin and all. Automatically that will be taken care through the Spring Boot application. Auto wire and all will have a, like suppose if you want to communicate it from one class to another classes, like a controller to service, service to repo and all. So for that we have auto wire annotations which will be automatically will create a respective class of bin. And then this type of main annotations are there. Apart from this, we can create a exception handler advice which will be handle the exceptions, common type of exceptions and all, create a custom exception. And then we have a transactional annotations, so that in a Spring we have a relational single mode of transactions, but here we are following transaction management, so that we have a multiple business or multiple database connectivity will possible in a single applications, or also multiple applications can be connected with a single database refreshed, and so that we can do. Apart from this, we have a multiple other annotations are there, but mostly other annotations which is common for a Spring also.
Mhm. Okay, okay, sure. So you mentioned about property files.
Yeah,
Sometimes we also use YAML files,
YAML
right?
file. Yeah.
What is the difference?
Uh, just a minute.
Hello, am I audible?
Amarjit, are you there?
Sorry for that. There was someone came. So like property and ML is main difference. Like both are same, but property, whatever the configurations we are defining for this, like multiple database is there. So for that we have a same repetition type of code we have written in the property, uh, like driver dot mongo dot connectors, that URL and then password and all. But while you use YAML file, then what are the repetition things is there that we can remove in there. So mostly line of code will be decreased, and that will be formed in snack YAMLs and all. So this is the main difference, right? So that will be based on key and value based. Hello.
Okay, yeah, yeah. Yeah, I had that. So how does the startup happen in Spring Boot?
A Spring Boot starter, right?
Hmm.
Yeah, Spring Boot starters like it's a features of Spring Boot. While if you want to create applications directly, you can go for a Spring Boot starter. So Spring initializers. In initializers, you can create all the dependency and respective things, and then create a jar file. So once you will create a jar file and you will import in your applications or in your local IDE. So whatever the respective jars you added, that dependency which I added in pom.xml, so respective jars will be loaded based on this Spring Boot starter. So suppose if you have mentioned Spring Boot starter as a 3.x version, according to that all the respective dependency which will be called from Maven and jars will be loaded in your library path.
Okay, sorry, I was talking on mute.
Okay.
So in the diagram that you showed right now,
Mhm.
um, yeah, can you share screen once again, please?
Yeah. Yes.
So over here,
Mhm.
uh, let's say one of the microservices, since there is a lot of split
Mhm.
uh, between the whole application flow,
Mhm.
if one of the microservices goes down, for example, the payment microservices is down,
Yeah.
how do you handle that?
Yeah, so we already told like we use a Spring Cloud component. So while we use a Spring Cloud component, we'll have a multiple features which will be applicable for microservice based architectures. Like API gateway is the first way. Others is Eureka service registry, which will be handled all the service register in all microservice register in Eureka service registry. Others will have a circuit breaker. So while you if any microservices is down, then how other microservice will know like this services are down. So we'll have a service register like Eureka service sorry what just a minute yeah, circuit breaker. So circuit breaker will know like circuit breaker will have options like while you are implementing any microservices, in that you have to add the circuit breaker dependency and write a business logic. While we are writing a business logic, there we need to add like two methods. One is the business logic method. If this business logic method is not performing, or maybe due to some of the violations and all services has down, in that cases we have a circuit breaker method. That circuit breaker method will call, and respective microservice will know like this services is down, please try after some time and all. So we need taken care all. And apart from this also we'll have like ribbons and all, which I told to handle the load balancers, service registry, and then configuration server, which will be configure all the YAML and all. So mostly
Okay.
use circuit breakers and all.
So what is the circuit breaker design? How would you explain that? Or you can explain with the example only.
Yeah, so in all the microservices, if I want to design a circuit breaker, so that circuit breaker, first of all, while we created a microservices, add the dependency of historic circuit breaker there in this, and after that create a YAML file. There we have to mention enable circuit breaker details in application property.yaml file. After there we have a enable a circuit breaker. So while you are writing this applications, then in this main class of a Spring Boot application you have to mention enable circuit breaker. And and then uh, and then while we handling the service.implementation class, there we mention histories and fallback method name. So that method name, suppose this method name is not worked, so that instead of the order microservice business logic, which will be called other method, is just of next method that will be show to the proper response. And also you can verify your changes or track the microservices detail in Histrix dashboard, because while you enable this Histrix, then Histrix will provide one dashboard. Through that also we can see the all things.
Um, this is mostly on like how do you configure, but what is the actual advantage of using it?
Mostly advantage is using to handle this microservices application. Once service is down, then how other microservice will know, and how other microservice will understand this our services is down, or maybe how business or customer will understand like service is down, please try later and all.
Mhm. Can you like explain diagrammatically how the rerouting will happen?
Rerouting.
Um,
From
so the example that we mentioned, okay, payment services, microservices, the
fail.
pods have gone down.
Okay,
So,
payment services has failed. Like okay, so
so
once.
from the Eureka services registry, when you're trying to contact,
Mhm.
uh, you are getting a timeout or something like that. A read timeout or an IO exception is what
Mhm.
you get.
Correct. Yeah. So if this payment service is down or something happen in that cases, they will send a Histrix response. So Histrix response will have a fallback mechanism. Fallback, either we have a fallback, Histrix fallback. Histrix fallback. So that Histrix fallback have some status will know the Eureka service registry. So Eureka service registry will pass to the store and order services. Like payment service is down, and they have sent this of the fallback ID details. So try after some time. We'll check this. Hello.
Yeah. So fallback is going to, so how wouldn't the user be, how would you like stop the user from knowing that, okay, something has gone wrong? Like, how would you make it seamless?
Uh, in that fallback method we have a multiple type of methods are there. Right now I'm not sure for that.
Mhm. Okay. So you mentioned you had also used Kafka, right, in between.
Yeah.
So how does the microservices communicate between each other? It's always through the services registry, is it?
Yeah, so yeah, the service registry will be there. So while it will go for the Kafka here, Kafka.
Mhm.
Yeah, so Kafka. No, that registry, service registry will register all those microservices. But if you want communications which have a handle huge amount of request on real-time processing, in that cases we will communicate it the Kafka. So that Kafka will be there in here. It will be here only.
Mhm.
Kafka will come in this way, like which will handle uh, like order details. So order details, once orders will be generated, then Kafka will have a uh, orders microservice will have a producers. So that producers will generate the data to the Kafka cluster in this cluster, and Kafka clusters and others microservice, if we want to process the business, then he want to update the store. So instead of direct calling to the order microservice, they will go for the Kafka here. And Kafka will check some any order has been created, what is the order ID. Based on the order ID, he will take the request. And then how, because store microservice will create a consumer, order microservice has created a producer class which have to generate the data in Kafka, whatever the data is coming from Eureka service registry to the order from the client, and then generate. And store microservice will have a consumer which will be consumed the data from cluster, and if he want, he can process. And then if you want to send the response, then directly again he will create a producer classes also and send it back to the Kafka cluster instead of order services. Like that same, we have a payment which have a success, failures and others response. Instead of direct calling to the other services, they will send it to the, while we use the saga pattern. So saga pattern, how it will come, in this Kafka clusters based only, the details will come, call this from Kafka and update.
Okay. Okay, I'm trying to figure out where is Kafka fitting. Okay, so how did you configure Kafka? Like topic wise.
Yeah, if I want to configure Kafka, first of all, whatever the microservices are there, that microservices, you add the dependency of Kafka, zookeepers and all. Then I add the configuration YAML in Kafka, topic name, keys, key replications and all in the application.yaml file, and create a producer or consumer class in particular microservices. Also create a Kafka configuration class, so that configuration class based on the details which you have mentioned in application.yaml, topic name and all, which will be configured and call. And after that uh, yeah, so after that, in the service implementation class, while you want to process the details, like publish the message, then you have a business which have send the request. So either send the request with from which form, either JSON and all, that you have to mention. If you want to get the request from the Kafka cluster, then in the service.implementation class, suppose payment microservices, so payment microservice implementation class will check what is the cluster name, what are the topic of order service. So based on the order service, the JSON data will be called. And based on the Kafka template, so they have to auto wire the Kafka template, and Kafka template, through that they will process to refactor this cluster data and take respective data.
Okay. So you were involved in like writing Kafka consumer and all that, is it?
Yeah,
Which Java version were you using?
Java mostly I used 8, Java 8.
Okay. So can you talk about the additions in Java 8 and what are streams?
Yeah, Java 8 editions have multiple editions features are there, Lambda functional interface, Lambda expression functional interface, method reference, optional, and Steam API, datetime API and all. So datetime API will have a, yeah, streams you ask. So stream is used to process the data. So while we process the data, we have a multiple intermediate and terminal operations which will be performed. And also we'll have a predicate, consumer and sub function is there. Through that we will process the data with the help of lambda expressions. So easily we can process the data with a short line of code through the stream API.
Okay. Okay. Let me give you a use case. I'm trying to put it out in the chat. Um, so let's say employee is the entity and you have details like name, salary, ID, age, etc. You have the info. about each employee. So let's say you have like collection of such employee details. So from the collection, we need to print out the employee names. Let's say Thomas, one employee, if he's having salary greater than 5K, we want those names to be printed.
Okay.
So
Yeah.
would you use a stream, or how would you iterate in Java?
AMP means here EMP, right?
Okay.
EMP.
Yeah.
And EMP within the secondary. Yeah, based on stream also we will do.
Can you try to write it down in Java?
Salary is less than 5K, okay. Salary is less than 5K.
I think you're not projecting the right window.
Sorry?
I can still see your diagram, not the.
Okay, I'm saying. No, it's fine.
Yeah, not bad here.
So here we'll have a list of parameter. Okay. Filter, okay, filter. Yeah, like that we can do like first of all we will process the employee list.htm.filter. Here we can enter this 5,000 of salary, and then through the map we will get this detail of who all have the salary less than 5K. Then collectors, then we have a collect the to list.
Okay. So is there any way for you to print in this line itself?
Which line? In the single line.
Like, is there a way to put an S out in this line?
Okay. Yeah, that also possible. System.out printed.
Okay, so what are the terminal operations here?
Yeah, terminal we'll have a like this one as a terminal collect
Okay,
collector, and intermediate we'll have a filters map.
okay. So when somebody is trying to use a list, what happens behind with respect to memory mapping?
If anyone will try to use a list, okay, so once you will take a list, then in collect, this is the part of collection framework, so that duplicate will be allowed here in list. So either you used array list, linked list and all, so duplicate will be allowed, and uh, while your space will be filled up, then again they will increase the size of whatever the array size, based on that divided by 2, so that space will be allocated either if you are using or not. If you are using, then fine, as if you are not using, so there is some space and all have a uh, non-usable space will be allocated. So that's why instead of array we can go for this other like set on
Okay.
implementation.
Mhm. Okay. Um, sure. I think that's mostly what I wanted to cover. If you have any questions for me, Amarjit.
Yeah, so for which domain and client you are hiring right now?
So it would be like for Java itself, and the project or the platform that we mainly deal with has microservices, nano services, and so on. And we use GCP. So a couple of expertise on those areas would be useful. We even have Kafka, Confluent, um, Apache also we have used.
Okay.
So there are multiple tech stacks that you've explained which we use.
Okay, sure. Yeah, thank you for this information. I understand.
Sure, thank you.
Yeah, thank you. Bye.
Meenashri, I think we are okay to close the call.
Yes, Anita, we can do that. Thanks for your time.
Thank you.
Thank you.
Bye.
Thanks, Anuj. Thanks for
Yeah,
joining
thank
the
you,
call.
thank you.